So how does this question differ from the ones we had before? We just have 2 points. We don't have the direction. So we know A is here, B is over here, and those are 2 points on our graph. So as far as our vector equation goes, you need a point, then a parameter gets multiplied by the direction. Now for our direction vector, all points in this line are going to be going from A to B in some form, either positive or backwards and negative. So how do we find out A to B? We go negative A and add B to figure that out. So A to B, which is going to be our direction vector, negative A, negative 1, 4, and then add 5, 8, we're going to get 4, 4 as our direction vector. So now when we go to make our vector equation of a line, you can choose any point for your point. So if you chose A and put 1, 4 here, that would be right. If you chose B and put 5, 8 there, it would be right. It doesn't matter which point. It just has to be any point on the line. Then our direction vector, since we figured out it's 4, 4, that would be right. But you could also have put 1, 1, because this is like a slope. And if you think of a rise and a run both being 4, you'd have the fraction 4 over 4, which could reduce to 1. Or you could write 19 over 19, or whatever you'd like. And now once we have this, we can write our parametric forms. X is going to equal 1 plus 4t. Y is going to equal 4 plus 4t. And our Cartesian forms, solve for t in both of those. X minus 1 over 4 equals y minus 4 over 4. So you can see why using 1 and 1 might be even nicer for your fractions, but it doesn't matter.